So let's come to this solution. Any ideas? Both the sequences consist of good limits. You can easily understand number one. Xn is greater than 0 and Yn is greater than 0, all of them by induction. Since x1, y1 both greater than 0, so xn, x2 and y2 will be greater than 0 and it will go ahead, right? By induction. And then you have so you have got all of them. So you can apply AMG. Why we are doing this? Because without this we cannot apply AMGM. To apply AMGM inequality. What is AMGM inequality? If A and B are greater than 0, equal to 0, then A plus B minus 2 root AB is equal to root AB minus root B whole square, which is greater than or equal to 0. So A plus B by 2 is greater than or equal to root B. Arithmetic mean greater than or equal to geometric mean. So that's the idea. It's given over here. And so we get that xn plus 1 is greater than or equal to yn plus 1. Okay. xn plus 1 is greater than or equal to yn plus 1. Okay. So if xn plus 1 greater than or equal to yn plus 1, what do we get? Xn greater than or equal to yn. So what do we get? Xn plus 1 and relationship between xn plus 1 and yn and xn. So xn plus 1 is half times xn plus half times yn. This is less than or equal to half times xn plus half times xn. Why? Because yn is less than or equal to xn. So you get it's equal xn is less than or equal to xn. Xn plus 1 is less than or equal to xn. So we get that this is what we get. We also get that xn is decreasing. And since xn is greater than or equal to yn, we get yn plus 1 is greater than or equal to yn. So we get yn is increasing. Did you get it, guys? Yn is increasing and xn is decreasing. Did you get this, guys? All of you?
Yes, yes, sir.
So please raise your hand if you didn't understand this.
I didn't get how yn plus 1 is greater than yn.
Oh, so yn plus 1, so xn is greater than or equal to yn. So xn greater than or equal to yn square. So this is a yn plus 1, right?
Yeah, got it.
All of you got it? Any doubts? Xn is decreasing, yn is increasing. Let's write it down. Okay. Yeah, Niket, yeah.
So I have used this similar technique, and I just want to mention that I am trying to use the monotone convergence theorem here to find the limits are equal. That is, I am combined that after that the result I have got that yn is increasing and xn is decreasing. So x1 is the above point, that is the upper bound, and y1 is the lowest point. In between these, all the values xn and yn are lying.
Yeah.
So now from the yn's perspective, yn is bounded above by x1 and xn is bounded below by y1. And
Okay.
After that, I am taking that yn. Then both of the sequence holds monotone convergence theorem, and let yn converges to L2 and xn converges to L1. Okay, so
Okay.
now then limit of n tends to infinity xn plus 1 is equal to limit of n tends to infinity xn plus yn by 2. So
Okay.
L1 equal to L1 plus L2 by 2. Thereafter L1 equals to L2. Is it okay?
Okay.
And
Let's
from
see. Let's see. Okay, I think I mean, what happens when you say your message, that's why I ask you to upload for solutions, okay, so that I can see that while you are saying. Okay, so it's very important to, therefore please upload your solution from next time, okay? Then
Okay,
so that
okay.
I can see your
So
message.
I have uploaded in the assignment group, my assignment classroom.
Okay, okay, but after that upload it here, okay, so that
Yes,
people can discuss.
yes,
Because I cannot open your assignment right here now, okay?
okay.
So yeah, I think you're on the right track. So what we have got from here is that xn is increasing. So understand this, xn is decreasing, yn is increasing, and xn greater than or equal to yn. Okay, xn is decreasing, so x1 greater than or equal to x2 greater than or equal to dot xn. Xn greater than or equal to yn, so xn greater than or equal to yn. Now yn is increasing, so yn yeah. So understand this is greater than or equal to xn plus 1. Why? Because xn plus 1 is average of xn and yn. So this is always less than or equal to xn. Okay. Average is always low. Assuming, so since xn is greater than or equal to yn, so xn is the greater one. Okay. So we know that the average lies between the two numbers. So xn greater than or equal to yn. This implies what? This implies that xn plus 1 greater than or equal to yn. Why? Now I think I am doing some mistake. Just give me a minute. Y is increasing, so yn less than equal to yn plus 1 होगा.
So thereafter xn plus 1, then yn plus 1, then yn. The inequality greater than continues in the next page. I think so. Here, yes, here after that this is xn plus 1, then yn plus 1, this xn greater than or equal to xn plus 1. Then xn plus 1 is greater than yn plus 1, yn plus 1 is greater than yn, that's yn is greater than yn minus 1, and so on continues up to y1.
Oh, what did I miss then? This is greater than equal to yn. Oh, yn is greater than equal to yn. Ah, okay. I don't know why did I miss in the middle. Anyways, since yn is increasing, so this is greater than this. And there is yn minus 2 greater than equal to not yn minus y1. So this means that yn is increasing and this means that x is decreasing. So we have got this inequality before. This is the other, this inequality we have already got, and these are the three inequalities we have used. Y increasing, Y decreasing, and this. So ये तीनों मिला के we got this. All of you understood this, guys? If not, please let me know. Raise your hand. All of you understood? Yes, write in the comments box. Okay, thank you. Superb. Thank you. Very good. So observe now that x1 and y1 are finite constants. Okay. So the entire xn and yn sequence is bounded. So xn and yn are monotone and bounded, and they have a limit. Have a limit, therefore. let's say L1 and L2, or Lx and Ly respectively. Now the question is that it's asking whether they are the same limit or not. They're the same limit or not. They're the same limit or not. So now,
So can you just take limit on both sides when we have that xn
okay, if
plus
you
1
take a limit on both sides, you will get that Lx is greater than or equal to Ly. But
no,
not
sir,
here.
not here. Now we know that.
In the recurrence relation. I mean, no.
Yeah, I'm coming to so yeah. Okay, yeah. Please go ahead, Sai.
So now we know that xn and yn both converge. But if we take limit on both sides, where we are defining xn plus 1 equal to average of xn and yn. So if we take limit on both sides, then we automatically get that x equal to y.
Okay, I think that's the idea. Let's do that. Yes, you're right. So if you now take the limit on both sides, you will get that Lx is equal to half Lx plus Ly. So you will get Lx is equal to Ly. Very good. Super. Yeah. All of you got a solution, guys? All are applications of modern convergence theorem. Very easy, right?